Hello, welcome to this 8th video on design patterns where we will study the iterator. This is the last video in the series on design patterns. The iterator is a behavioral design patterns, and remember that we have also studied the observer in the previous video. Right, the purpose of the iterator is to provide sequential access, traversal strategies to the elements of a collection that is sometimes called the aggregate. The idea is not to expose, not to reveal the internal representation of this collection. For example, you may have different types of lists like linked lists, array lists, and you would like to traverse this list independently on the implementation details. It's also known as the cursor pattern. You may already be familiar with the iterator because it's very popular in computer science, and many programming languages they provide support for it, for example in Java. As additional motivation, suppose that you have a list and you need to traverse that list, but without revealing the internal structure, whether you have the elements in an array or use a linked list or whatever. Moreover, you may want to traverse the list in different ways, for example, backwards or forwards, but of course you do not want to have many methods within the list for the traversal, because whenever you want to have another strategy, you may need to add new methods, and at the end you will have a lot of methods in the same class, and that's not good. On the other hand, you may want to have a collection and you may want to have different traversals simultaneously. Right? So the solution here is separate the collection from the iteration strategy. And so the idea is that the traversal responsibility goes to a class which is the iterator class. Let's see a first attempt to implement an iterator for lists. Here I have my class list, and then what I do is separate the iteration strategy in a different class, which we call list iterator. You see that the list iterator has a reference to the list that is iterating, and then it has an index, the cursor, to know which element of this list the iterator is visiting. Then it has methods to go to the first position, to the next position, to get the current item, and to know whether we are at the end of the iteration. Well, this has the advantage that we have separated the traversal mechanism from the collection, so that we can perform several traversing processes, or we can define different strategies for iterating. However, this is not the full solution, right? Because, for example, we don't have a common a common interface for all possible iterators. I may have additional iterators, but I don't have a common interface. Here I have just one concrete class. I would need to define a common interface, for example, for forward, backward iterators, and so on. The iterator and the client are also coupled. So how do we know which iterator to use for a list? Well, we need to know that there is a class list iterator, and also if there are different types of lists, we need to know which concrete type of iterator should we use. And also, there is no common interface for creating lists, so that we don't have a base class for the different types of lists. Let's see a better implementation. Now what we do is we have, on the one hand, a common interface for the different types of lists, where we have elements for the list, like counting the number of elements, adding or removing elements, but also what we have is a method to create iterators. Then we have two types of aggregates. We have two types of lists. We have a skip list, which is a special type of list with a data structure which optimizes insertion and queries. And we have a list. So these two concrete types of aggregate will implement these methods, and in particular you see that they will provide support to create the right type of iterator, because we have a list iterator to iterate lists, and we have a skip list iterator to iterate skip list. Both iterators, they follow the same interface, which is the class iterator, where you see that we have common methods to go to the first, next element, to check if we are done with the iteration, or to get the current item. So we have separated the collection from the traversal strategies, but the responsibility to create the right type of iterator is given to the abstract list. And now I have a question for you. Which other pattern are we using here? You can stop the video and think for a moment. Well, it's very easy once you notice that each list is responsible for creating their own iterator. So you see that we have an abstract method here, create iterator, to be overridden in skip list and in list. And this creates an object of type list iterator or skip list iterator, both of them of type iterator, which is the return type of this method here. So of course, if you have studied the videos of design of previous videos of design patterns, you notice that this is a factory method. When shall we use the iterator pattern? Well, when we need to access the content of an aggregate collection, for example, without exposing its internal representation. In the previous example, we had two types of lists, a skip list and a list which can be based on arrays or a linked list, and we do not want to expose how it is really implemented. Also, if we want to have several traversal strategies on the aggregate, for example, forward or backwards, or we need to define a uniform interface to traverse different types of aggregates, for example, skip list, linked list, array list, or whatever, that is to allow polymorphic iteration. This is the general structure of the pattern, where notice that we have four main roles. On the one hand, we have the aggregate, which is a common base class for all the types of concrete aggregates. In the previous example, this was abstract list. Here, we may have additional methods, but we need to have a factory method create iterator. This create iterator will be overridden in concrete aggregates and will create the appropriate class of concrete iterator. The idea is that each concrete iterator will conform to this interface here, whose name is iterator, and will provide methods to traverse the given aggregate. Then we will have different types of iterators to traverse different types of concrete aggregates or to implement different traversal strategies. This is a summary of the role of the different participants of the pattern. On the one hand, we have the iterator that defines the interface to access and traverse the elements. Then we have concrete iterators that implement such interface, and in addition they maintain the current position on the traversal of the aggregate. Here we may have different iterators for different types of concrete aggregates or for different strategies. Then we have the aggregate that may define common methods for the given collection type, and it should define the interface to create the proper iterator. This method will be overridden by concrete aggregates that will implement suitably this method to create the right type of iterator. How does it work? Well, let's see it with a sequence diagram. So we have a client class here that wants to traverse this concrete aggregate. For this purpose, the first thing I need to do is to create the iterator, and basically here I'm creating a concrete iterator. Normally I will pass the concrete aggregate as a parameter of the constructor, and then I will return the iterator here. So once I have the concrete iterator, the client first goes and call method first to set the concrete iterator to the first element, and then it may, for example, call method isDone to know if there are more elements to traverse. Then typically we will have a loop that will be repeated until there are no further elements. And then we will be able to get the current element. And when I call current item on the concrete iterator, the concrete iterator will need to access the concrete aggregate and get the element of the index. Index will be typically an attribute of the concrete iterator. Then it will get the object that will be returned to the client code. And again, we will call next and we will call isDone. Well, this is an example code for the iterator pattern where I'm using interfaces here. So I have an interface for the iterator that basically has the methods and an interface for the aggregate that contains the createIterator method. Well, this example, you may not like it, I do neither. It's a very simplified. For example, one obvious improvement is that I'm using here objects, so both iterator and aggregate could be generic interfaces. Well, but the point is that I have a class list iterator that implements the iterator and basically receives here the aggregate and stores the aggregate, has an index which is called current, which is initialized to 0, and then is initialized to 0 again with first, with next I increase it, and then isDone basically checks that current does not overpass the number of elements in the aggregate, and the current item simply gets the item from the aggregate. Again, here I'm using object. This iterator could be a generic class. Regarding the implementation, it's important to know that there are two types of iteration. One is called external, which is the one we have seen here. We create an iterator, we call first, we call isDone in a loop, and then we call next and current item. That's the external way to iterate. But recall that in the streams and lambda lesson, we saw that we can iterate via strings, and these are called internal iterators. Basically, the iterator receives a function to apply, and then it automatically traverses all the elements applying the function. Right? This is similar to a stream over which you apply a map. That is called internal iteration. Of course, this is all familiar to you because in Java there is a very nice implementation of the iteration pattern. As the aggregate, you have, for example, the interface for collections, sets, order sets, lists, and so on, where remember you have a method iterator that returns a generic iterator. Then you have concrete aggregates, for example, each implementation of those interfaces like hasSet, treeSert, linked hasSet, and different types of lists. And then the iterator, you have the iterator class, which has methods hasNext, next, and remove. And concrete iterators, there are concrete implementation of iterators. The style is external iteration, where typically this would be the way to use an iterator. So you have first a concrete aggregate, you obtain the iterator, and then you iterate using hasNext and next. Well, this is the last video about design pattern, so let us draw some conclusions. The design pattern helps you to create applications using proven solutions. These proven solutions, they form a catalog of design patterns. As we have seen, there are different categories of patterns, and they will help you to avoid reinventing the wheel again and again. And if you know these design patterns, you will quickly find good solutions to your problem. Moreover, you will be able to communicate quickly with your colleagues by saying, I'm using here the composite, you should use the iterator there, and so on. The list of design pattern is not static, but is growing because we are capturing the knowledge from design experts, and the number of design patterns is growing every day. They help you to have better designs, more extensible software, and to facilitate exchange, reuse, and improvement. And again, remember that these are not libraries. These are design guidelines that you can follow and adapt to your given situation. We finish with the bibliography. You can have a look at these 3 books, but remember, this is the original book with the original list of design patterns.